In the spring of 1655, a 32-year-old French mathematician named Blaise Pascal locked himself in a workshop somewhere in central France and tried to break the laws of physics. He was, by every standard of his era, brilliant. He had invented a mechanical calculator at the age of 19. He had, along with Pierre de Fermat, founded the entire mathematical field of probability theory in a series of letters in 1654. He had conducted the famous barometric experiments that demonstrated the existence of atmospheric pressure. He was a religious mystic, an essayist, a frail and chronically ill man who would be dead inside of 7 years. And in 1655, he set himself a problem that he believed his mathematics could solve. He wanted to build a machine that would, once set in motion, continue moving forever, perpetual motion. The dream that had obsessed natural philosophers for at least 3 centuries by the time Pascal took it up. A wheel, frictionless or nearly so, balanced so perfectly that any nudge would set it rotating indefinitely. The energy of the rotation would be available, in theory, to do useful work: pump water, drive looms, illuminate cities. The economic implications were staggering. A working perpetual motion device would have been the most valuable single invention in human history. Pascal worked on the problem for an undetermined period. The historical record of his actual workshop activities in this period is thin. Pascal himself rarely wrote about projects he abandoned, and his sister Gilberte's biography of him, which is the principal contemporary source for his life, skips over the perpetual motion attempt in a single sentence. What survives is the device he produced. It was a wheel, mounted horizontally, balanced on a fine pivot, notched around its rim with 36 numbered slots. It did not work. It could not work. The second law of thermodynamics, which Pascal could not have known because it would not be formally articulated for another 200 years, makes perpetual motion impossible. Friction, however slight, will eventually bring any closed mechanical system to rest. Pascal's wheel, however precisely machined, did the same. He set it spinning, it slowed, it stopped. He abandoned the project. And here is where the story takes the turn that gives this video its title. Because Pascal did not throw the wheel out. Within roughly 20 years of Pascal's death in 1662, French gambling houses had begun installing a device that was, in every important mechanical respect, the wheel he had built. The historical record of the transmission is incomplete. Nobody knows exactly who took Pascal's design and adapted it for gambling. The likeliest path, traced by the historian of mathematics David Bellhouse at the University of Western Ontario, runs through the salons and gaming rooms of late 17th century Paris, where Pascal's scientific work was widely discussed, and where his mechanical apparatus was, apparently, gathering dust, waiting for someone to notice what else it could be used for. By the early 1700s, what would later be called roulette, French for little wheel, had become a recognized feature of French gambling. By 1796, Parisian gaming houses had standardized the wheel into something almost identical to what now sits on the casino floors of Las Vegas: 36 numbered slots, alternating red and black. A small ivory ball spun against the rotation of the wheel. The bet placed before the spin settled after the ball came to rest. The mathematician who could not break the laws of physics had, by accident, given the world the device that would extract the most money from the largest number of gamblers in any continuous gambling operation in modern history. Every roulette wheel currently operating in every casino on Earth is a direct mechanical descendant of Pascal's failed perpetual motion experiment. The wheel he could not make rotate forever has been rotating, with brief interruptions, for 350 years. To understand how that wheel works as a financial instrument, and how it makes money mathematically, without exception, over time, you have to follow a small modification that was made in 1842 in the resort town of Bad Homburg in what is now Germany, by 2 French brothers named François and Louis Blanc. The Blanc brothers were professional gamblers. They had been operating gaming concessions across Central Europe since the late 1830s. They were also, both of them, gifted amateur mathematicians who understood probability theory at a level that almost none of their competitors did. And they had identified, by the early 1840s, the structural problem with the existing French roulette wheel. The problem was that the French wheel was too fair. The standard Parisian roulette wheel of the 1830s had 36 numbered slots, plus one slot marked with a 0. The 0 gave the house a small mathematical edge, roughly 2 7/10% on most bets, which was enough to ensure long-run profitability, but not enough to generate spectacular returns. Competing casinos in Wiesbaden, Spa, Aix-la-Chapelle, and other continental gambling resorts were running similar wheels and competing aggressively on house edge. A casino that ran a lower edge wheel attracted more players. The race to the bottom was eroding margins across the entire industry. The Blanc brothers ran the opposite play. They opened a casino in Bad Homburg in 1842 with a redesigned wheel. They kept the 0. They added nothing visible, but they did something subtle that would change the structural economics of gambling forever. They removed the second 0. Other casinos at the time were running wheels with 2 0 slots, a single 0 and a double 0, which gave the house a 5.25% edge. The Blanc brothers' wheel, with only 1 0, gave the house a 2 7/10% edge, exactly half. Players noticed. Players migrated. By 1843, the Bad Homburg Casino was the most profitable gambling operation in Central Europe. The Blanc brothers had figured out the central insight that every successful casino operator since has rediscovered. The house edge does not need to be large. It needs to be consistent. A small edge, applied to a large volume of wagers, compounded over time, generates more revenue than a large edge that drives players away. By 1854, the Blanc brothers had been invited to take over the casino at Monte Carlo, in the tiny Principality of Monaco, where a struggling royal family had concluded that legal gambling was the only available economic strategy. The Grimaldi family, which had ruled Monaco since the 13th century, was effectively bankrupt by the middle of the 19th. Prince Charles III had inherited a country roughly the size of New York's Central Park, with an annual royal income that barely covered the upkeep of the palace. He needed a revenue stream. François Blanc offered him one. The deal Blanc negotiated in 1863 became the foundation of Monaco's entire modern economy. The Société des Bains de Mer, the sea bathing company, a deliberately innocuous name for what was in practice a gambling concession, paid the royal treasury a fixed annual sum plus a percentage of casino revenue. In exchange, Monaco abolished income tax on its residents and granted the Société a monopoly on all gambling activity within the Principality. The arrangement still exists in modified form today. Monaco's citizens still pay no income tax. The Société des Bains de Mer is still partially owned by the Grimaldi family. The roulette wheel turned a bankrupt principality into one of the wealthiest per capita jurisdictions in Europe. Within 10 years of the Blanc takeover, the Monte Carlo casino had become the most famous gambling establishment in the world. The Blanc-designed roulette wheel, single 0, French-style layout, low house edge, was its centerpiece. Aristocrats traveled from St. Petersburg and London and Vienna to play it. The English novelist Charles Garvice, the German composer Richard Wagner, the Russian writer Fyodor Dostoevsky. Dostoevsky lost so badly at Monte Carlo and the German Spa casinos in the 1860s that he wrote an entire novel about the experience, The Gambler, published in 1867, partly to pay off the debts the wheels had given him. The roulette wheel, by this point, was no longer simply a gambling instrument, it was a cultural one. It was the canonical symbol of European leisure-class wealth and ruin. And here is where roulette acquires the mathematical signature that has defined it ever since. The single 0 European wheel has 37 slots, numbers 1 through 36, plus a single 0. A bet on a single number, if it wins, pays 35 to 1. The fair payout would be 36 to 1. The difference between those two numbers is the entire house edge. Specifically, on every dollar wagered, the house retains, on average, 1 divided by 37 of the wager, which works out to 2.7%. That is the entire mathematical engine of European roulette. 2.7 cents on every dollar, forever, across every spin, across every player, across every casino on Earth that runs the European wheel. The American wheel, which the Blanc brothers refused to install at Monte Carlo, kept the double zero. Modern American casinos run the double zero wheel because it generates almost twice the house edge, 5.26%, on the same equipment. The American player, sitting at a roulette table in Las Vegas or Atlantic City, is mathematically paying nearly double what the European player is paying at the equivalent table in Monte Carlo or Baden-Baden. Most American players have no idea this is the case. Now consider what that 2 7/10% edge does over time. A roulette wheel in a busy casino spins approximately 60 times per hour. Each spin accepts wagers from typically 8 to 12 players. The average wager varies enormously, but a representative figure for a mid-range European casino is around €50 per spin per player. That works out to total table action of roughly €500 per spin, or €30,000 per hour. At a 2.7% house edge, that single table extracts, mathematically, €810 per hour, 24-hour operation, 365 days. A single European roulette table, if it operated continuously at moderate volume, would extract over €7 million per year for the house. The Monte Carlo casino, at its peak in the late 19th century, was running dozens of these tables simultaneously, 2 7/10%. That is all it is. That is all it has ever needed to be. Pascal had been trying to build a machine that produced energy out of nothing. The wheel he abandoned, repurposed, produced money out of nothing instead. The mathematics that he could not bend to physics turned out to bend perfectly to probability. The wheel does not need to spin forever to be profitable. It only needs to spin long enough for the law of large numbers to do its work. If you are finding this useful, hit subscribe. We cover deep histories of everyday money like this every week. Now, the part of the roulette story that almost everyone has heard, and almost no one understands correctly, is the story of the men who, despite the mathematics, won. Because the wheel can be beaten, the mathematics guarantees long-run profitability for the house. The mathematics does not guarantee profitability for the house in any particular session, on any particular day, against any particular player. Roulette has been beaten repeatedly throughout its history. The methods are well documented. The casinos know about them. The methods still occasionally work. The first documented case of a player beating a roulette wheel through systematic exploitation rather than luck is the case of Joseph Jagger in 1873. Jagger was a Yorkshire engineer. He had spent most of his career working in the cotton mills of West Yorkshire, fixing and maintaining the heavy industrial machinery that powered British textile production. He knew, from professional experience, that no mechanical device, however precisely manufactured, is ever perfectly balanced. Every spinning wheel in a textile mill had a slight imbalance that caused it, over time, to develop characteristic patterns of wear. Jagger reasoned that the same principle would apply to roulette wheels. In the summer of 1873, he travelled to Monte Carlo and hired 6 clerks. He stationed each clerk at a different roulette table in the casino. Each clerk's job was to record every number that came up on their assigned wheel over the course of an entire day. Jagger paid them out of his own pocket. He told the casino nothing. After 6 days of observation, Jagger sat down with the data. 5 of the 6 wheels showed numerical distributions consistent with random chance. The 6th wheel did not. On the 6th wheel, 9 specific numbers, 7, 8, 9, 17, 18, 19, 22, 28, and 29, came up significantly more often than the other 28 numbers. The deviation was small. It was also unmistakable. Jagger walked into the casino on July 7, 1875, sat down at the biased wheel, and started betting on his 9 numbers. He won. He won steadily. He won. Over 4 days of play, approximately £70,000, equivalent to roughly £7 million in modern money. The casino's managers, after watching him win for 3 days, finally figured out what was happening. They moved the biased wheel to a different table while Jagger was sleeping. The next morning, Jagger sat down at what he thought was his usual wheel and began to lose. It took him approximately 6 hours to realize the wheel had been switched. He moved tables, found his biased wheel by checking for a small scratch he had memorized on the wheel's frame, and started winning again. The casino, by this point thoroughly alarmed, brought in technicians overnight and physically rebalanced every wheel in the building. Jagger left Monte Carlo with approximately £65,000 in winnings. He returned to Yorkshire, invested the money in real estate and railway stock, and never gambled again. He died in 1892, 20 years before the song that immortalized